Hello guys, today we will be looking into a Ladybug software, which is a plugin tool for Grasshopper, which is used to analyze and visualize weather data. So this is the website Food for Rhino, where you are able to download this plugin. Once you get onto this page, you will see some information regarding the tool and what devices it's compatible with. So it's compatible with Windows and Apple as well. And once you go down, these are some downloading options. I would recommend getting getting the download which is compatible with your Rhino. So in my case, I've got Rhino 7. So I've downloaded the latest version that they had at the time and downloaded that one. So that's compatible with me. I will be skipping this step since I already have Ladybug installed onto my device and it's in Rhino. But once you've done this, it will automatically show in your Rhino on here. So once you open up Grasshopper, which it will do shortly, you can see the plugin of Ladybug here, and it's got all the tools that you'll be required to do this analysis for. Alright, so to do this, we will take Cadmapper, we'll go to their website, and for this example, we'll download a file that will be used for the analysis. So in Cadmapper, I'll do this again. So you get to the website and you go at the bottom where it says to create file. You click on this, and here, as you can see, it says that you can get a free file for up to 1 kilometer square. So let's take a very small piece. So this is the Melbourne CBD, and we'll just take a small section of this area, let's say. And since it's within, I don't have to pay for this, and you just go create file. And once you've clicked on that, they will give you a preview in a axonometric view to see if you are happy with the location and the sizing and what you can see in that downloaded file. I'm happy with this, so I will just download it. And you just close this, and they have downloaded this as a zip file. Now we will just extract that file. So you go into the downloads, open up the file, and just extract it all. And now you can just delete the zip one because you don't need it. So once you've clicked on this, you can open up the Cadmapper Rhino file. And while that's opening, let's just quickly download the EPW file. So we'll go EPW Ladybug, and you click on this. So EPW is pretty much a weather file which contains all the data for all these locations. So now that amazing. So let's go into the area where we've downloaded the file. So it'll be around this area. So EPW, they've got multiple ones. You can download anything. I'll download this. And once that's downloaded, it will also again give you a zip file. We'll just have to extract that. So let's go to downloads again. And here you can see all types of files. EPW is what is required to do this example that I'm going to show you today. So you just extract this file, and then you go back, and you can simply just delete the zipped one. So here you can see you've got the EPW, which is the most important one. All right, so let's go to our opened file that we got from Cadmapper. Let's just put this, so our default, it's always in wireframe. We will put this in shaded so it's a bit easier to see. And you can just press enter and Rhino will do the same command that you did at the very last. Alright, so this is the file that we received from Cadmapper. Let's get this, and before going into Grasshopper and Ladybug, let's just quickly clean this file. So let's choose one of the buildings that we want to do the analysis on. So let's say this is my main building. Let's create a new layer. Main building. And you right click on that and do change object layer. Just to change the color so you can differentiate and see where exactly it is. Now let's lock it and turn this off. And we'll select the rest except the topography because it's not needed. And select that as well. And you just get a new layer and just write the surrounding buildings. And you just change their layer and the rest. Let's lock this one and turn this off, and the rest can be deleted just to make this file a bit smaller. Amazing. So this is what we're working with now. Let's open up. Let's also just delete the rest of the layers that are not needed. And delete that one as well. So it's not deleting it merely because I'm on it. So now let's delete the layer. Amazing. So now that everything is been deleted, let's open up our Grasshopper file again. And choose file path. So this just helps us to create, add a file that is not imported in Grasshopper or Rhino. It's in the device and it's able to locate that location. So you just select one of the existing files since we have already downloaded it. And this is our EPW file. You select that one and you click OK. And now we go into importing the data into our Ladybug tool. So we add the Ladybug import EPW file. And since that file is within this container, you just click on this and drag it into that. So this is an output, this is an input and this is an output. So an output goes into an input and then the data from here goes into here. Amazing. So now we just have to create sun path and direct sunlight analysis. So let's start with the sun path since we need some data from that sun path to do the direct sunlight. So you need a north. So you double click in an empty area and you write vector and you right click on that container and set one vector. Once you do that, it'll give you an arrow and this pretty much can be changed anytime, but it just shows where north is relocated. So my north for this drawing, for this CAD is at the very top. So I just put my arrow at the top and click OK. And then put my north in there. Then for the location, you set the location here. So once you do that, your sun path, let's look to the perspective. So this is the sun path that the sun will take. So your east is here, which is correct. Our north is at the top, which we fixed, which is also correct. So the sun will take from east to west direction. So we know that this data is correct that we're getting. Now let's fix up the center point as well, because we would like to show the red building in the middle and then this sun path going around it, and we can change the scale of it as well to have a better visualization. So let's put a point in, and this point will go into the center point. So you right click on that and you set one point. It's best to do this in a top view since it gives you a bit more accuracy. So let's just pick the middle of this building and you set OK. And you just drag it to the center point. And now our sun path is in the middle. Let's also change the scale of this sun path. So let's try 1 to 15. So by adding 2 dots, it gives you the scale. So it's going from 1 to 15. This can also be changed by right-clicking and going to the value section. But for now, let's just go with this one. And then you just go up and voila. I think this size is very good. Don't think it needs to be changed, but just play around with it to see what you find the most compatible for your design. So for this example, we will just keep to this size. And now our next exercise is how do we get the sun points and the sun. So the data is already there in terms of where the sun is going from. We just need the sphere, so a shape of a sun, which is just this, which is perfect. And then you grab the sun points data that you've received and you put it in B. That did not work. Let's have a look. So you no, don't. Sorry about that. Let's just get rid of this one first. Let's first do the analysis period, which could be why it's not working. So you need to show, not this one, sorry. So it's the analysis period Ladybug tool. I think this is why it's not working. So before doing that step, you will need to do this, which is to write specific time, which hasn't been yet added into the Ladybug tool yet. So for example, for this one, for summer, let's do a summer solstice day, which I believe is on the 21st or 22nd of December. So you'll get another slider and you just write 12 for December. So this is the day. So you put the start day and the end date. To put 2, you hold shift and it shows you the plus arrow. So you just click on that and take it to the end day. Same, let's do the same for this month. So it's start month and end month. And that's all we need to do. Just to make this file a bit more organized, select the days and the months and the analysis period. Right click and let's group it. You can also name your groups. So this is summer solstice. And then you take the hoist and you put it in the hoist in the sun path. Now you can also see the points are now showing up here. So this is how the sun takes its route during summer solstice. Now let's do the step again where you create a shape on those points. So now we've got the sun points. You put them in B. They're still not showing. It may be because it's quite small. So let's change the radius. Let's go with 10 to 30 and drag that into the radius. Now you can see that there's some spheres up on right in the middle of those points. We can change the sizing as we go up and to your desire, stop whenever you'd like. Let's go with 23 for me. So this is the sun path analysis for summer solstice. Now let's do one for the winter one as well. So you click on this and try to drag it and then press Alt. That lets you copy it. Now let's change this month to 6 June, and you just change that. I think it's on the 21st of June, the winter solstice. And again, just to organize this file a bit more, we group them and we name this winter solstice. Amazing. Now let's disconnect summer solstice by right-clicking on the hoist and going to the disconnected option and take our new analysis for winter and put that in again. And now it's showing our winter sun. To compare the two, you can grab both of them. So our winter is already connected, and let's connect our summer. It shows both of them here. Amazing. So this is how you do the summer and the winter analysis, sun path analysis. And now let's get into how we can do direct sunlight analysis. So you double click on an empty space and you write direct sunlight. So here we go, direct sun hours. Click on that. And all the data that we need is already in here. Then there are a few things that you'll have to do in Rhino, but otherwise everything else is done in Grasshopper and Ladybug. So you take this vector, as you can see, we need vector here. You take the vector, drag it in to here. Let's also use set one of the geometries that we'll be putting the direct sunlight on and the context around that geometry. So you double click again and you write burp. Burp is pretty much used to set geometries. So you right click on that, and for the geometry one, we will use just one burp since we're only using one of the geometries to shine the sunlight hours. So you click on that, and once you do, you select your main geometry. In my exercise, we will be using the red one as the main one. You click on it and it selects it for you. Now in Rhino, you are able to, let's do this. In Rhino, you are able to turn this layer off, and the grasshopper layer will still be on here, so it's easier to see. So let's just name this as the main geometry and press enter, and you go in here. Let's do the same thing for our context. So you double click and create burp, and this time we will do multiple burps since we've got a lot of buildings and lines for the context. Once you do that, you just drag it and everything that you'd like is selected, and then you press enter. Now let's just create a new layer and then hide the rest. So this is context buildings, and this is our main geometry where the sunlight analysis will take place. Click on that and let's work on the grid size. So let's start with 0 and 10. We'll experiment with these numbers, but let's just get the grid sizing correct first and we'll work on the rest later. Amazing. So for it to run, I know it's not running at the moment, so it needs a toggle button. So right now it's at false. So let's get a toggle, Boolean toggle. So right now it's set as false. So once you click on it, it becomes gray, but it still isn't working, mainly because it hasn't been told for it to run. So you double click on it and here you go. This is how it looks. Let's quickly just turn this false and just have only one of them connected. So at the moment, our summer solstice is connected to the direct sunlight hours. And now let's do this again and change just hide these, maybe not just the main geometry, to see just the colors. And this is how it looks. So since it is the summer solstice, the hours, let's go into this view, and you can see here, you get 9 hours of direct sunlight on this side of the building. Let's just change the grid sizing as well to see how it looks. So it changes colors quite quickly. It is recommended to make this false first, and let's just make this maximum number to 30, let's say. Alright, let's work with maybe 21 and then create this, and it shows a bit more detail into what's happening and how it looks. So if you go again, so you can see here, this number has changed. So it's showing 15 hours of direct sunlight at the very top of the building. This makes sense because our summer sun path is right at the top of the building. So this data set seems correct and very accurate. Now let's make this false again. And let's put, instead of the summer one, let's put our winter analysis into the hoist, and then you press true again, and this is the difference between how the building is receiving direct sunlight in winter. So let's look at the hours. Yep, so this hour has changed to 10 hours, which makes sense since the sun is now at the back of the building, so it's not receiving as much as it was during summer, which was right on top. And this is how you do the summer and winter sun path and direct sun hours on a specific geometry.